Hello guys, and welcome to this video on Cramer's rule. So this is also one of the past questions that normally repeats itself. I took this from 2015 and 2016. So for this set of equations below, use Cramer rule to solve for the value of xj, where j is 1, 2, 3. So they want us to solve for x1, x2, and x3 using Cramer's rule. So let's dive into the solution. So to solve this problem with Cramer's rule, I'm going to show you a pretty straightforward approach that might be a little different from what you know, but if you apply this convention, it will save you a lot of stress. So you can call your x1 as delta x1 over delta naught, okay? Your x2, sorry, will be delta x2 all over delta naught, and your x3 is going to be what? Delta x3 all over delta naught. So this is how we are going to configure our system, where delta x1, delta x2, and delta x3 are some 3 by 3 matrices, some configuration of 3 by 3 matrices that we are going to obtain by this system that is given to us. And delta x naught is one of the matrices that comprises of the coefficients of the variables in question. So we are going to start by evaluating delta x naught, which is the determinant of the coefficient matrix. So delta x naught is the determinant of the coefficient matrix. So how do we build it? So we are just basically focused on the coefficients. Okay, so the coefficients. So the coefficients, I'm going to copy this out so that it will make it easy for us to not scroll up and down. So I'll put it here, and we are going to build our 3 by 3 matrix like this. So to build our 3 by 3 determinant matrix, you can see I've changed the brackets to straight line. So the coefficients of the variables, okay, I'm not talking about my constants, I'm just looking at the variables. So I have 1, I have 3, I have 2, then I have 2 minus 1 minus 3, then I have 5, and I have 2, and then I have what? 1. Is that okay? So this is the matrix that comprises of what? The what? Coefficient. The determinant matrix is the coefficient of the variables in question, and that will give me delta x naught. So let's quickly evaluate delta x naught. So to evaluate delta x naught, I'm going to expand along this first column. Remember, is plus minus plus, so you can expand anywhere you want. I'm just expanding along this first column because it contains like a biggest number, so I like expanding along column that contain like the biggest number. So you can feel free to expand it anyhow you know, but just follow me and you will see how I'll do it like this. So delta x naught is, so when you take 1, we are going to get the minus of 1. The minus of 1 is this matrix over here. So minus 1 times 1 is what? Minus 1. Then 2 times minus 3 is, you know, it's minus, so it will become plus 6. Is that okay? Then there's a minus 2 into. So what are the minus of 2? So if you cross this one out, you have this, and this. So 3 times 1 is 3. Then 2 times 2 is minus 4. So this times this minus this times this, and finally plus 5 into. So the minus of 5 is this matrix over here. So 3 times minus 3 is a minus 9. Okay, then minus 1 times 2 is going to give you a plus 2 over here. So 3 times minus 3 is minus 9 minus minus, then the product of these two. That's why it became plus. Okay, so delta naught is going to be, so you can just use your calculator to solve it so that you can avoid error, because this problem is very error sensitive, so you don't want to make any mistake, because if you make mistake at first, that's the same mistake you carry and solve for all other values. Okay, you use this delta naught to solve for x1, x2, and x3, so you don't want to make mistake when calculating it. So let's pop up our calculator and just evaluate this. So 1 times minus 1 plus 6, then you now have minus 2 into 3 minus 4, then you now have plus 5. So I was supposed to put the times here, sorry. Plus 5 times into minus 9 plus 2. So this gives me negative 28, as you can see. So negative 28. Is that okay? So please, if you're not very good with evaluating this kind of calculations quickly, there's a high tendency that if you do it quickly with your hand, you run into errors. So since you have access to a calculator, just work with calculator to avoid errors. Then now that we found delta x naught, we'll go ahead to find delta x1. So how do we build the matrix delta x1? It's easy. So let me show you. So this is the system of equation that we're given. So in order for me to build delta x1, I'll build it as a determinant that comprises of. Now, I'm going to leave the column for x1 empty, and I'll fill in for x2, which is 3 minus 1, 2. Then you now have what? 2 minus 3 and 1. So you can see I filled in these two columns for x2 and x3. So to find delta x1, all you just need to do is to replace the coefficients of x1 with the constant term here. So you have what? 3 minus 8 and 9. So this is how to find the matrix delta x1, and that is how you subsequently find your delta x2 and delta x3. So to build the matrix, the determinant matrix for delta x2, you're going to fill in columns for x1 and fill in columns for x3, while you're going to replace the coefficient of x2 with the constant term. So when you want to get your delta x3, you fill in columns for x1, fill in columns for x2. Then instead of you to write this coefficient for x3, you replace it with the constant term. So building this delta x1 is all about replacing this position coefficient with the constant terms. Is that okay? So I hope we are good on that now. So now that we've gotten hold of that, we can now expand. So my delta x1 is going to be what? My delta x1 is, I'm going to expand along this first column, plus, minus, plus. So we'll start with 3. So we'll get the minus of 3, which is this matrix over here. Minus 1 times 1 is minus 1. Then this times this is going to give you a minus 6, but since you're subtracting, to become plus 6. Okay, this times this minus this times this gives you this. And you now have, coming to this next element is minus, so minus 8. Okay, minus 8 into, so what are the minus of 8 with respect to this configuration? It will be this, and this. So 3 times 1 is 3, and 2 times 2 is 4. So this times this minus this times this gives you 3 minus 4. And finally plus 9 into, so we are going to take the minus of 9, which are the determinant of this subsection, giving you 3 times minus 3 is minus 9, and minus 1 times 2 is minus 2, but since you're subtracting, it will become plus 2. Is that okay? So calculator to the rescue. I don't want to stress myself with my head. So you now have minus 1 plus 6, then minus 8, which I know is already plus 8, but let me let the calculator think for me. I'm too lazy to think. I don't want to make any mistake. That's basically, so minus 9 plus 2, so we got minus 56. Okay, speed of light. So delta x1 is equal to minus 56. Now you need to understand that you are in an exam and you want to do everything within your grasp to have what I call time advantage. So one of the way you can do that is by making use of your calculator. Since we've gotten delta x1, we can calculate our x1 to be what? Very good. Delta x1 over delta naught. Okay, so this implies that delta x1 is negative 56 and delta naught is negative 28. if we still remember where we calculated delta naught, okay, over here. So if you do this division, you're going to get 2 as your answer. Is that okay? So you can pause the video now and try to calculate delta x2 and delta x3 and divide it by delta naught so that you can get the corresponding values for x2 and x3. So when you're done, you can unpause it to see how I'm going to solve it in my own case. Is that okay? So I'm sure you must have done that. So let's dive into the solutions for x2 and x3. So remember that x2 is delta x2 over delta naught and x3 is delta x3 over delta naught. So to build delta x2, we already know that this is our system of equations. So just like we said, we're going to replace all the positional coefficients of x2 with the constant term. So instead of me to have an x2, why am I still writing this as supposed to be a straight line for determinants, not matrix? So I'll fill in the coefficients for x1, which is 1, 2, 5. Then instead of me to fill in the coefficients for x2, I'll replace it with the constant on the other side of the equation to 389. Take note, as I'm replacing with the constant, I'm not changing their signs. Their sign remain exactly as it is. Now, there are different explanations of Cramer's rule. There is a one that the signs would change depend on how you configure your system. That one, they usually take the constant to the left hand side, and what you have on the right hand side is just 0, 0, 0. So in that case, you could actually do some manipulation, but I feel that one is kind of like too complicated and sign sensitive, but this one is straightforward. So for anyone you want to find, just replace the coefficients there with the constant term exactly as it is on the right hand side, then solve. So since it's only x2 we are looking for, we'll leave the coefficient of x3 like that. We'll now expand this determinant. So where are we expanding from? Yeah, should we do something funny? I thought maybe you would have tried to expand from this row, from this column. Well, what's the harm in being flexible? You can expand from anywhere you want to expand from, but I'm going to take the risk of expanding from the middle column because it contains the biggest number. So this is minus plus minus. So let's see how it looks. So we have delta x2 is going to be, if you start with this, you have minus 3 into, so what are the minus of this particular element over here? So you have this, and this. So 2 times 1 is what? 2, and 5 times negative 3 is negative 15, since you're subtracting to become plus 15. Okay, then plus 8, so you have plus, but 8 is negative, so minus 8 into, what are the minus of 8? Minus of 8 are the elements at the edges, this, and this. Okay, so 1 times 1 is 1, then 5 times 2 is 10, so 1 minus 10, like this. And finally we go to 9, which has a negative sign according to our code matrix expression, so matrix signs, sorry. So you have minus 9. So what are the minus of 9? The minus of 9 is this, and this. Okay, so you have 1 times minus 3 is minus 3, and 2 times 2 is 4, so minus 4. Is that okay? So again, calculator to the rescue. So we have minus 3 into 2 plus 15, sorry, minus 3 times 2 plus 15, then plus minus 8 times 1 minus 10, then minus 9 times minus 3 minus 4, and you have 84. Okay, 84 is the answer. So delta x2 gives us 84. So therefore x2 is equal to delta x2 over delta naught, which is going to be 84 divided by negative 28. This is minus 3. So 28 times 3 gives you 84. So when you do the division, you can get it like this. So finally, we can now go on to evaluate our delta x3, which is going to be a determinant formed by replacing the coefficients of, okay, the terms x3 with the constant terms. So instead of x3 here, I'll have 3 minus 8 and 9. Then x1 and x2 will remain the same. 1, 3, 2 minus 1 and 5, 2, like this. So we can expand the determinants. This time around, I'll expand from here, from this last column. So my x and delta x3 is going to be, I'm expanding from the last column which has a plus, minus, plus. So we have 3 into, so what are the minus of 3 with respect to this position? We have this arrangement here, 2 times 2, 4, minus 5 times minus 1 is minus 5. So it will be 4 plus 5 because you're subtracting. Is that okay? So take note of that. Then you now have minus 8. Since it's minus, you have minus minus 8. So minus is from the matrix sign positioning, and this other minus is from the minus 8 itself. So you have to take the minus of 8, which I believe is this, and this. So 1 times 2 is 2, and 3 times 5 is what? Minus 15. Is that okay? And finally, we have plus 9 into what? The minus of 9 with respect to this position is this, and this. 1 times minus 1 is minus 1, and 2 times 3 is 6. Okay, so again, calculator to the rescue. You have 3 times bracket 4 plus 5. I do 4 plus 5 is 9. Wow, I'm still gonna use my calculator on my thing. And you now have 2 minus 15. I know 2 minus 15 is negative 13, but I'm still using calculator. What's the difference? So 9 times minus 1 minus 6. Okay, where did I make the mistake? Okay, I didn't put the times here. This my calculator is very sensitive. So I have minus 140. So delta x3 is equal to minus 140. So this implies that my x3 is delta x3 over delta naught, which is negative 140 divided by negative 28. And this is nothing but 5. 28 times 5 gives you 140. So in summary, x1 is equal to, we got 2, x2 is minus 3, and x3 is equal to 5. So this is the use of Cramer's rule to solve system of equations. So I hope you understood and you appreciated this method, and I hope you learned something new. Please work with your calculator because there is no time. Okay, so thank you for watching. Please like this video, share, subscribe to my channel, and hit the notification bell to stay updated. I would love to hear your comments in the comment section, and till the next video, stay safe and stay blessed. Bye.